Well now, I've made a thing. It's going to be quite hard to show you, I think. I'd better use a torch, I suppose. As you can hear, I've got the engine running, and I've got, as I say, a thing which I will endeavour to show you. So down here, I have this Arduino thing, which obviously needs to be packaged and so on. It's connected into power, obviously, but one of those wires you can see in the background is going to the rev counter connection, which, as you can see, currently showing just under 1,000. And I've got this thing going on, which is a digital readout of lots of things, including engine RPM. So that's showing 790, and this is showing, what is that exactly? It could be 800 and something. So maybe a slight calibration, very slight calibration issue. But the point is, the important thing is these relays here. Now these relays here are there to simulate VVT and the two IMT controllers, and they are simply working on this device, which is an RPM sensitive relay controller. Now you certainly won't be able to feel what I can feel, but I'm holding these relays in my hand now, and I'm going to rev the engine slightly, and I think the first switch on speed is 3,000 RPM, so got that going on. There it goes. Did you hear it? Possibly you did. Little click going on, and if you look at the screen, with IMT1 has come on, and then it's gone off. On and off. So I'm pretty pleased with that. That's been a fair amount of work, because obviously you can't just constantly run with the engine running, so I've had to create a pulse generator to simulate the engine running as well as the thing itself. There it is, and it needs to be packaged up and so on and so forth. But I mean, that's providing me a function which Motorsport Electronics ME360 doesn't provide, which is a number of relay controlled outputs that depend on engine RPM, and that's really what I was looking for. Simply engine RPM. It's not sensitive to load or anything like that, and nor is it resulting in the use of PWM. It's just a relay on and off, and the valve open and close, which will be more like it was in the Jaguar system anyway. So now I need to take it back in, and I will look carefully at the switching RPMs. I'm quite pleased actually that the RPM is quite close, so that's near as damn it 1,000, whereas screen down here is giving me 870, so it's probably about 100 RPM out. But that is just an adjustment in the code. Very, very easy to adjust. So that's what I need to do next. So back on the bench, here is the Arduino thing. Here are my captive relays. And yes, it looks a bit of a lash up, although it's a kind of circuit board. It's not actually on a breadboard. This is actually soldered, and it has actually got diode protection, a voltage regulator, and all of that, so it can run on the car. So it's not a complete lash up, but I need to do some small changes. So here, in a slightly more indoorsy type of situation, we've got this. And it's on a much bigger screen, and you can see the display. This is a serial connection to the Arduino thing, and you can see this is the number of times that the program has run, doing about once a second. And here is the simulated engine speed, and telling us whether the IMTs are switched on or the VVTs are switched on. And we have a simulated speed of 4,500 RPM, and in fact everything is switched on in this situation. And down here we have my control knob, which I can twiddle, and we can see that we've now got a crazy fast simulated RPM. So let's go the other way. And there we are, a slower one, a bit more sensible. And you can hear the relays clicking. And you can even see on my scope here the pulses racing across the screen, doing their thing. So there we are. That's a slightly more visible version of what we saw outside in the car. So in order to correct slightly my RPM reading in the middle, 2254, we need to raise that up about, I guess it's a percentage. That's going to go with, it was about 100 RPM too low before, 100 out of 1,000 being around 10%. So we need to get that figure of 2254 to be like 200 higher, like 24 top 54. Now the thing is, it's actually a calculation which I can show you in the code. There we are. Where is it? There it is. RPM is 9 million divided by another number. So if we increase that figure slightly, probably by about 10%, we should get a slightly higher figure. And there we have it. Without changing my speed control knob, without touching that at all, our figure is now, rather than 2254, I think it was, it's now around about 200, which is 10% higher than that. And I've done that simply by changing this calculation over here. So rather than 9 million, it's now 9,700,000. So probably have to calibrate that again to the engine, but there's probably a limit to how precisely accurate it even needs to be, but that will certainly do for the time being. So we've raised the display figure by about 10%, which then more closely agrees with the rev counter on the dashboard. Right, well, after a considerable amount of work, we've now got a rather neater version of the VVT and IMT controller, which looks like this. I mean, it is the same thing inside the box, but it's in a box, and we've got some tidy wiring. And in fact, I've decided that the VVT on left and right bank, they don't need separate controls. So they are going to be controlled by this relay. It's going to do both left and right to avoid that problem that we had before, where only one bank was being VVT'd, if that's the word. So we've got the upper and lower IMT control, and we've got a selection of, let me get you a bit closer, we've got a selection of switching RPMs, which in fact, thanks Kev Tier, I've used your figures for the VVT, and I expect they will be fine. But the IMT controls I've taken directly from the Jaguar manual. Well, here's a different thing. So I've now connected up my Arduino setup, let's say, to the engine, and as you can hear, it's running. So what do we got then? So what we got here is the what's it called? Mighty, yes. We've got the Mighty software set with the VVT page, and overlaid onto that we've got this terminal thing which is connected to my Arduino setup, which, as you can hear, is recording the, or as you can see, your RPM. Right, here we go. So it's currently it's interesting actually, because you can see, if I can move this thing down a bit, so my RPM, which is only a calculation, is pretty similar to the management system RPM. It goes, right, I'm not going to touch it now, but you can see that the RPM here, 950 or something, is now not far off. And we have the status of IMT 1 and 2. And in fact there is only one VVT now, because I've got them connected up to the same thing. So if I rev it, you should see all of these things, items, change from off to on. Here we go, the VVT came on. And well, there we have it really. Now I mentioned that the disadvantage of using my sort of homemade Arduino controller for the VVT, IMT and all that is the fact there's no test modes as there is with Mighty. So I had to make my own little program that does all that. We've got here. And I've got an unreliable relay. So we've got different IMTs, and then VVT over there. But it's looking to me as if the relay itself is a bit unreliable. And this might be illustrative. Also, it's hanging like a right mess again. So we've got 3 relays, IMT1, IMT2 and VVT, which if you listen carefully you can actually hear working. But frequently the VVT one doesn't. But I might just swap over the relays. Of course this is unfortunately one of the relays that is partially melted, which is probably why it's a bit unreliable, but unfortunately it's the only one I've got available. Alright, so I've now got my port numbers correct, which were indeed wrong before. That was using the test function. Well, I've now re-uploaded the RPM sensitive control, and hopefully it should now work. Well, I can report that it does appear to work. I won't be able to demonstrate in a sense that you will be able to know at this stage. But let me just demonstrate what I am able to do. So I'm holding the relays in my hand, and because you can't hear them with the engine running, I can just tell you. Switched. And it's stalled. So did I come off the VVT too quickly? Maybe. Anyway, so I suppose I now need to connect up the Mighty so we can look at cam angles and stuff. Yeah, so it sounds quite good, doesn't it? Not sure any of this would have made much difference apart from maybe cam A VVT definitely being off, which it might not have been before. Cam B is also definitely off. All this variation here is just noise, really. Why it should not be changing to approximately 30 like this one on cam B. Sorry, cam B is a bit of a mystery. At the moment it could be a wiring issue, it could be the VVT beta, or it could be some other phenomena that I don't know what it is just yet. But anyway, I think that's for another day, tomorrow in fact, and a test drive as well. But one thing is looking quite good is the fact that both these figures are actually now pretty much stable, and what that suggests to me is that the PWM activation of those solenoid valves for VVT on this early AJ30 engine, it may have been not fully off. Don't know, but anyway, it's certainly worth moving to the next stage with it, and I'm interested that the idle seems to have stabilised. Is that just a coincidence? Maybe, but maybe not. And just another little afterthought, the engine's quieter. At the moment it seems to vary kind of randomly. Sometimes it's a bit rattly and other times not. But what I'm wondering is whether the VVT valve likes to be a bit open to stop it from rattling or something. And if that's the case, obviously then that will have effect on the static cam angle. So I forget what the figure was that we had for the cam A settings before, but it's 9.5 I think it is. This is the offset that enables it to read 0 basically. Here we've got 595. It certainly wasn't that earlier on today, but I think I had some cross wiring, so that may not even be relevant. So there we are. It does, like this is an improvement. Right, so I have now actually replaced my dodgy relay, which is this one that works sometimes. I've now got a new one. It's quite nice that it has a light on it, but it only works sometimes, so that's going to go in the bin. And now we have my test function working as it should, so you can hear it. Top one, bottom one, VVT. Alright, so that's that problem. So, well, what I haven't got sorted out is, well, according to the Mighty software on the engine management system, it looks like the cam angle on cam B That's this one isn't varying. This one is fine, does 30 degrees, but this one fiddles around, don't know. So I'm now going to have to investigate just in case it's some wiring problem. I don't think it is, but let's see. Right, I've changed my test program. It's now only doing VVT, which you can hear. You can just about feel it as well. Now this one is right under here. And it's really, I can't get my hand in due to this inlet thing. But I do wonder if it's faulty. Now, because the VVT valves are actually controlled by the same relay now, unlike previously, it's just a simple matter of unplugging something. So now I've only got this valve working. And as you can hear, pity you can't see anything. You can hear it's clicking away nicely. And note the noise. Pretty solid click. And compare with the other one. And now this is the other one. Exactly the same noise. So whatever the problem is, it's not to do with wiring or software. It can only be the valve itself, and it doesn't sound any different. So if there's a problem, yeah, I think it has to be the valve itself. But anyway, I suppose what is required now is more testing. Right, so after all that malarkey, let's see what's happening on the management screen. And I've got the setup for looking at my Arduino box as well. So here it is. So effectively this is my VVT screen, although there's no actual VVT enabled on this. So we've got the current advance on cam A, we've got a current advance on cam B, which is unstable still, but the VVT valves are switched off, and our RPM is a bit wobbly, idle, but it's kind of pretty much in agreement with between here and here. It is a calculation, so I'd like to be precisely correct all the time. In the case of this is reliable, but this is a calculation, so not quite reliable in terms of the precise number. But anyway, right. So if I rev it slightly, we should see IMT and we should see VVT probably more easily, because currently that's set to come on at 1800. But we should see something happening. Current advance on A and B in collaboration, as it were, with VVT on. Yeah, so we've got VVT on cam A, but VVT B is not happy. So anyway, there it is, and it seems to be roughly correct, but I think I'm going to have to invest in a new VVT valve for VVT-B. That's what it looks like to me. Right, as you can see, I've started to take the engine to pieces a bit. I've taken the inlet manifold off completely, revealing this. It really is a V6, it's not just a straight 3. Yes, there is another set of cams over here. And what I'm going to do is I'm going to take off the cam cover, which will enable me, that's my bonnet catch assembly, which requires me to wedge it up somewhere out of the way. So that will enable me to access the cam actuator valve, which is just here. So as you can see, I've now got both cam covers off, because it does strike me that the easiest way, in the absence of a spare cam control valve solenoid, I could swap it from the other side. And if I swap it from side to side, we'll see if the fault follows it. And this side is a lot easier to get to pieces than this side is. So we'll put that one over here. Well now, after a bunch of work, taking the cam covers off and swapping over the VVT valves, it now is like this. Now there's a couple of foibles that I keep on coming across, one of which is it is very rattly running, and the other one is to do with my program. Now the rattly running at the moment is absent. It's pretty smooth, possibly a little bit fast, but we'll live with that. And this is the screen here running 994. Now I've got this terminal here. I can't run the management system at the same time, unfortunately, because I've got a dual boot system running Linux Mint, and Linux Mint is very capable of talking to my Arduino thing, but not to the Motorsport Electronics ME360, unfortunately. But it does seem to be better at talking to the Arduino thing than the equivalent Windows, so I don't know why that is. But anyway, the point is that it does something a little bit unexpected. Now, I'm not sure if I can demonstrate it. Now, you'll have to listen to what's going on, so I'm going to shut the window here. Try to. Why is it not shutting? Oh, yes, I do want to shut. Okay. So now if we fire it up again, I think it might do the same thing as it did last time. Come on. Oh, okay. Where is it? Yeah, did you hear that? There was a little stumble just then. And that is because in my startup program, I've got a thing where the system runs for a moment and it opens and shuts the VVT and the IMT valves. Now, obviously, I don't really want that happening every time the engine runs, and certainly not when I start and stop this little program. But so my program is actually enabling the system to run more quietly without the seeming tapping, which is obviously coming from the VVT sprockets on the cams. Now I'm going to come back to the main thread. So it was a lot of work to swap over the VVT solenoids from left to right. But seemingly it's made absolutely no difference at all. And I don't know why I'm getting that revving up behaviour. I'm going to have to reboot my system and come back and see what's going on. So after a lot of tweaking work to my Arduino program, all detailed stuff to do with how long does it take before it starts up properly, resetting, I don't know, lots of little tweaky things. Oh, actually one of the most important things was I discovered that if you leave the computer plugged in like I was doing, then the thing doesn't reset. Right. So the Arduino itself is now powered from the computer rather than from the car. That caused me a lot of confusion. But anyway, yeah, so when I start the car after some sort of alteration, I have to disconnect the computer, switch the car on. That clicking noise you heard was the VVT valve resetting. And now we can start up, and we will have the management program working. We will also have the monitoring program for my Arduino. And you might have heard it clicking away there. And we can start the engine. And if I bring up the VVT screen, I don't know what's going on with cam B. That is a mystery. So I've switched over the VVT actuators, and it's still doing this, even at idle, whereas cam A, rock solid. Anyway, let's pull up the actually there may be a thing. Look, can you hear a slight tapping noise? There we are. After a slight pause, the system does a reset, and that gets rid of the rather annoying cam actuator bracket that happens over there. But if you do a quick reset on the VVT, it goes away. I think it must be something to do with the oil-powered hydraulic system pumping up sort of thing. But anyway, whatever it is. So and there we have it. So the VVT, hopefully you saw the VVT change to around about 30. I've set it for 2,800 RPM. I may end up changing that. This Kev tier recommended 1800, but I found that it was too close to idle speed, so that it was still, the VVT was still actuated as you come off the throttle. I think that was happening. So anyway, I've put it up to 2800, which is obviously not perhaps quite as good as it were, but anyway, that's where it is at the moment. But yeah, the VVT is being operated not by the ME360 but by my Arduino thing, which I will pull up, and there it is. Let's pull this over here, and if I rev up a little bit you should see this change to VVT on. IMT on, and the thing idles. I don't, like I say, it's going on with cam B. Let's do that, looking at cam B again. So we now know it's nothing to do with the cam actuator, the VVT actuator. So possibly my cam B, maybe the cam sensor is playing up. But both VVTs are actually connected together. So if one's on, they're both on in reality. So a bit strange. Yeah, I may invest in a new cam sensor on that side. I could swap them over, I suppose. They're a heck of a lot easier to swap over than the VVT actuators, I can tell you. But anyway, whatever, in a sense it doesn't matter. So I can even change, or we're not even syncing on cam B at all. We're all U6 being at the moment. So yeah, I reckon that's as good as it's likely to get before a rolling road session. And we've even managed to improve the mapping. So we can look at the AFR. And I've done a lot of tweaking down here, but it seems to be in the range of 14.7, which is what we want. You do get this strange thing of the idle speed going up. I'm not sure what that's all about. Yeah, and I suppose I'll just take you one other thing that I had to do. So when you take engines to pieces, all of this stuff and the cam covers and everything, one of the things, because it had got damaged before, is the cylinder head temperature sensor, which was damaged and it actually broke. So I have actually had to do some surgery on it. So that seems to work now, as evidenced by the coolant temperature reading a sensible figure, whereas yesterday it was reading -15. Basically it was disconnected. So anyway, I suppose there could be another test drive, but essentially I think this is my VVT sub-project finished. You've seen me driving around previously. It's a very fast car, and I can't really demonstrate that. Maybe I'll get a G meter or something at some point, or maybe I could do my 0 to 60 time. Yeah, interesting. But anyway, this could be the end of this particular sub-project.